In this video, we're going to be looking at another elimination reaction. This time we'll be looking at a dehydration reaction, which just means we're going to be removing water from a molecule. So we're going to start with our general reaction scheme. Here we see that our reactant is an alcohol. We have this H plus over the arrow, so that's an acid catalyst. So the acid is going to be regenerated during the reaction. So it's not actually a reactant. Our products are an alkene, which is our organic product, and water, which is our inorganic byproduct. So we really care about that organic product, that alkene that we're going to form. So I'm going to show this reaction with an actual molecule, and we'll do our most simplistic reaction we can. So we'll start with ethanol. So C2H5OH. So we have our ethanol. We react that in the presence of an acid catalyst. So this OH is what we call a leaving group. It's going to part the molecule to form that water. And it's also going to take with it a hydrogen from the adjacent carbon. So we're going to end up with an alkene, so a double bond between our carbons. And then water, HOH. So we're going to walk through the reaction mechanism. Once again, you don't need to know the mechanism for Chemistry 30, but it might help you understand what's happening and why we need that acid catalyst. So I'm going to start with our ethanol molecule again. Okay. So we have an H plus, so we basically have a free proton. H plus is considered an electrophile. So it's looking for centers of negative charge. Our oxygen here in our hydroxide is very electronegative, and it has lone pairs of electrons. So those electrons can grab that electrophilic hydrogen, and they can form this molecule. So we have that hydrogen now stuck to the oxygen, positive charge there. All of our carbons still have 4 bonds. So now we have this water molecule kind of hanging out. That water molecule is much more stable on its own, so it's going to steal these electrons from carbon. Now, carbon is going to have a positive charge. So we draw this again. We'll have all of our hydrogens still kicking around in place. Except now we're missing a bond on our carbon. So this has a positive charge. We would call this a carbocation. Not super stable. And so what's going to happen here is the hydrogen is actually going to leave and give its electrons to those carbons. So it's basically going to move those electrons between the carbons. When that happens, we form a double bond because 2 electrons form a bond. So we form a double bond. We stabilize that carbocation, and we regenerate our H+. So this is our regenerated catalyst. Now there are lots of variations on this mechanism depending on the type of alcohol you start with. This is an overly simplified version just to kind of help you have a better understanding. We're going to walk through an example now where we can form multiple products with our dehydration elimination. So we're going to start with this molecule, OH. So I'll just give that a quick name. That is 3-methyl hexane 3-ol. So that's a tertiary alcohol. So when we add an acid catalyst to this alcohol, we're going to be removing this OH. And so the carbon to which the OH is bonded is going to be involved in our double bond. That carbon is attached to 3 other carbons. So I'll highlight one in yellow, one in green, and one in red. In order for these carbons to also be involved in a double bond, they must give up a hydrogen. So these carbons must have at least one hydrogen. So we can check. The yellow carbon has 2, the green carbon has 3, and the red carbon has 2. Because all carbons need 4 bonds. So there's 3 possible products we can form here. So I'm just going to draw them all out and then I'll name them color coding so we can see where each of them formed. So that's going to be 1. That will be product 2. And product 3. Now you don't have to know which one is going to be the most common to form. You just have to be able to predict which ones could form. So this first one is going to be called 3-methyl hex 2-ene. So that's formed when a hydrogen is taken from the yellow carbon. When a hydrogen is taken from the green carbon, our parent chain then becomes pent, and we have 2-ethyl pent 1-ene. And finally, if we take a hydrogen from the red carbon, we end up with 3-methyl hex 3-ene. So always be looking, are there different products that could form? If you have a secondary or tertiary alcohol, the answer is usually yes.